The Mystery of Time: How Humans Invented the Clock. Imagine waking up tomorrow and discovering that nobody knows what time it is. No 7 a.m., no lunch at noon, no meeting at 3, no flight leaving at 8:45, no countdown to midnight. For most of human history, that was completely normal. But then something strange happened. Humans became obsessed with measuring something they couldn't see, couldn't touch, and couldn't stop: time. And the story of the clock is much stranger than you might think. Because the first clock wasn't mechanical, it wasn't made of gears, and it wasn't even designed to tell you what time it was. Chapter 1: Before Clocks. Thousands of years ago, people didn't ask, "What time is it?" They asked, "Where is the sun?" The position of the sun was humanity's first clock: morning, midday, sunset. Simple. But there was a problem. The sun disappears at night, and clouds can hide it during the day. So ancient civilizations needed something better. One of the earliest solutions was the sundial. The idea was incredibly simple. Put a stick in the ground, watch its shadow move. The shadow became a pointer, and the ground became the clock face. But here's the first big mystery. Who invented the first sundial? We don't actually know. Ancient Egyptians were using shadow clocks more than 3,000 years ago, and similar devices appeared in other civilizations. The technology was so simple that different societies may have discovered the idea independently. And that tells us something important. The desire to measure time wasn't invented by one genius. It appeared wherever humans needed to organize life. Chapter 2: The Clock That Didn't Need the Sun. Now imagine you're an ancient Egyptian priest. It's nighttime. You need to perform a ceremony at a specific hour, but there's no sunlight. What do? You use water. Around the 2nd millennium BCE, ancient Egyptians developed water clocks, or clepsydri. A container slowly released water. As the water level changed, markings indicated the passage of time. No sun required. No shadow. Just gravity. And suddenly, humans had a way to measure time at night. But there was a problem. Water doesn't always flow at exactly the same rate. As the water level drops, pressure changes, which means the clock can become inaccurate. So people had to get creative. They changed the shape of the containers. They added markings. They experimented with different designs. The history of the clock is basically the history of humans trying to defeat one enemy: inaccuracy. Chapter 3: Time Becomes Mechanical. For centuries, people measured time using shadows, water, candles, and other natural processes. But then, somewhere around medieval Europe, something revolutionary appeared: the mechanical clock. And here's another mystery. Historians still don't know exactly who invented the first mechanical clock. There is no single person we can point to and say, "That's the guy." Instead, the technology seems to have emerged gradually during the late 13th and early 14th centuries. And the first mechanical clocks weren't designed for your bedroom. They were enormous, complicated, expensive, and usually installed in towers. Why? Because the most important customer wasn't an individual. It was the community. Churches needed bells to signal prayer times. Cities needed a shared schedule. And suddenly, time became public. Imagine hearing a giant bell ring across your entire town. You didn't need a watch. The town itself had a clock. Chapter 4: The Strange Device That Changed Everything. Early mechanical clocks had a major breakthrough: the escapement mechanism. It allowed gears to move forward in controlled steps. Tick, tock. Tick, tock. Instead of time simply flowing through water or shadows, a machine could divide it into regular intervals. This was a profound change, because now humans weren't just observing time, we were engineering a machine to measure it. And that changed society. Suddenly, an hour could become something standardized. A schedule could become precise. And eventually, every minute could matter. Chapter 5: The Clock Enters Your Pocket. By the 15th and 16th centuries, clocks were becoming smaller, much smaller. Eventually, mechanical technology became portable. Enter the pocket watch. Now time wasn't just hanging from a tower. You could carry it. You could own it. You could check it whenever you wanted. But there was still a huge problem. Mechanical clocks could lose or gain time. And for most ordinary life, that wasn't a disaster. If your clock was 5 minutes wrong, who cared? But then humans started doing something that made 5 minutes extremely important. We started traveling long distances. Chapter 6: The Mystery of Longitude. Imagine you're a sailor crossing the Atlantic Ocean. You know where north is, you can observe the stars, you can estimate your position, but there's one enormous problem: longitude. Knowing your position east or west was extremely difficult, and this wasn't just a scientific puzzle, it could be a matter of life and death. Ships could get lost, ships could miss their destinations, ships could crash into coastlines. Governments offered huge rewards for a practical solution. And eventually, one of the most important breakthroughs in clock history appeared: a highly accurate marine chronometer. The challenge was brutal. Build a clock accurate enough to keep time on a moving ship despite changes in temperature, humidity, and motion. One of the people who finally solved the problem was an English clockmaker named John Harrison. His work in the 18th century helped make precise longitude determination possible. And suddenly, a clock could help you find your way across an ocean. Think about that. A machine designed to measure time became a navigation instrument. Chapter 7: Why do we have 60 minutes? Now here's a question you've probably never asked. Why does an hour have 60 minutes? Why not 100? Why do we have 60 seconds in a minute? The answer goes back thousands of years. Ancient Mesopotamians, particularly the Babylonians, used mathematical systems based heavily on 60. And 60 is actually a remarkably useful number. It can be divided evenly by 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. That made it extremely useful for mathematics and astronomy. The system survived, and thousands of years later, you're still using it. Every minute, every second, every day. Ancient mathematics is literally ticking on your wrist. Chapter 8: The Clock That Changed the World. Then came the Industrial Revolution. And this is where the clock stopped being just a tool and became a force that controlled everyday life. Factories needed workers to arrive on time. Trains needed standardized schedules. Businesses needed opening and closing hours. Factories needed shifts. And suddenly, being 5 minutes late wasn't funny anymore. It could cost you money. The clock became a symbol of discipline. Time became money. And eventually, entire societies began organizing themselves around the clock. Chapter 9: The second that wasn't really a second. But scientists had a problem. Mechanical clocks weren't perfect. Quartz clocks were better, but even quartz clocks weren't perfect enough forever. So scientists went deeper, much deeper, into the atom. Modern atomic clocks measure time using incredibly stable frequencies associated with atoms. And in 1967, the international definition of the second was changed to something based on the behavior of the cesium-133 atom. That's right, the second you just experienced is ultimately defined by something happening inside an atom. The same species that once watched shadows on the ground eventually built machines capable of measuring time at an astonishing level of precision. Chapter 10: We don't even need clocks anymore. And then something even stranger happened. We stopped carrying clocks because clocks became computers. Your smartphone doesn't just tell time, it communicates with networks. Your smartwatch can measure your heartbeat, track your location, and synchronize with global time standards. GPS satellites depend on extremely precise clocks, and without that precision, your location could quickly become inaccurate. So the clock isn't just sitting on your wrist. It's in satellites above your head. It's inside communication networks. It's inside financial systems. It's inside the infrastructure of modern civilization. The final mystery. But after thousands of years of inventing better and better clocks, there's still one mystery we haven't solved. What exactly is time? We can measure it, we can divide it, we can synchronize it, we can build machines accurate enough to measure absurdly tiny intervals. But we still can't stop it. We can't store it. We can't reverse it. And every clock ever built has been doing the same thing, ticking away while we move forward. From a stick in the dirt to a shadow on stone, from water to gears, from pocket watches to atomic clocks. Humanity spent thousands of years building better ways to answer one simple question: what time is it? But perhaps the more interesting question is, what is time? And that is a mystery our clocks still haven't answered. If you enjoyed this journey through the strange history of time, subscribe, because the next time you look at a clock, remember, you're looking at one of humanity's oldest obsessions, and its ticking has been following us for thousands of years.